where you can expect to find up in Canvas the notes. You can expect to find the answer key to the notes. And while I'm doing this, for sure, I'll have videos of them, just like I did last semester. Okay, first thing I want to talk about is what's up here. What is this chart? Yes. So now look at it. Dig into the data a little bit. What can you interpret from this chart? Well, yes, but I've put them in order, right? The top is the best score and the bottom is the least score. I've got 4 classes. It's not necessarily by period. I just put them in order by best to least so that I didn't call anybody out and go, you guys are awful. Yeah.
Except for the best side, all of the short answer questions.
Okay. Substantially or just kind of like these guys, yes, right? That's kind of a significant drop. Like this is pretty close. And honestly, I like that, right? The idea that the short answer and the multiple choice gave similar results. And certainly in this case, it's very consistent overall, right? Like the scores they got were well represented by either the short answer or the multiple choice. Here, it looks like the multiple choice was a little bit easier than the short answer. Again, here. And here it looks like the short answer was a little bit easier. But generally, that's a pretty good thing. And we wrote this test for you guys this year so that all geometry students at TAM would take the same final exam, no matter which teacher they had. Towards that end, I feel good about that alignment. That's one piece I look for. The second piece I look for is this column. What does that tell us? Yeah. True, you're reading the data correctly, but that's not what I look for. How do I use that tool? Yeah, true. Yeah, like the test doesn't represent content that nobody learned.
Yeah, but what if they have like a tutor and they take like 5 billion different classes?
Very possible. I think the fact that all classes had at least one person earning a really high A tells me that the content was aligned. And I'll tell you the way I created the final exam. I actually wrote the final exam. The way I created the final exam is I created the skills list that I used for my instruction with you. And I shared it with all the other teachers. And I said, which of these skills should we just teach in class and not really worry about testing? Which skills should be tested in class? And which skills are so important they should be presented in class, tested in class, and on the final exam? And I only chose from those ones that were on the final exam. So every skill here was also on your tests. And that's why I felt good about this, because not only did I choose content that you were exposed to, but it's pretty clear that it was doable content. It wasn't crazy twisted stuff. And then lastly, the median. What's a median mean? See what I did there? Statistics joke, yeah. It's one of the averages, right? We've got median, mean, and mode. Mode means what shows up most often. Mean is the average. That's what these all are. What's the median? Middle, right? If we took all of the scores and ranked them from highest to lowest, the median is the spot where there's exactly half above and half below. No. And that's important. When I see, for example, a 73 overall average and a 75 median, that means it's a pretty normal distribution. But when I see something like an 8-point gap, this is where the median is.
Someone's dragging down that class.
Yes, that's exactly the way to interpret it. When the average is significantly lower, you've got people who are down here. And those are concerns for me. As a teacher, how is it that I've got students that are pulling in 15% on a final exam? That's rough. So I have posted all your scores. Everything is up on Canvas and on Synergy. I want you to look at it. I've got a few more days left before I actually submit grades. You decide if it's ready to go. I think it is, but I may have made a mistake. If I didn't enter something I was supposed to enter, if you think I misrepresented something for you, if I forgot to add something that you know you submitted on time, please contact me. I'm not looking for you to say, you know, I really feel like a B student. I know I did a C level of work and I got C's in all the tests and I got a D on the final exam, but I feel like a B student. Can you bump my grade up? That's not what we're looking for here. Yes. They were bumped because of all the people on Zoom and the people who are out, can't make up tests and things like that. There's a couple of people who have not yet taken the final exam, usually because of COVID, sometimes for different reasons, and everybody needs to take the final exam. In the event that you don't have a grade that you're happy with, I want you to think about what you can do differently this semester. Because I think there's a fair number of people who did like 73% of the homework, right? Is it easy to get A's on the homework for me? Yeah. It is, right? At a minimum, I post the answer keys. You could go copy the answer keys, submit them, and get 100% of the homework. That's not what I'm looking for. Half the answers? Oh, I think it's more than that, but you're right. Sometimes I miss. But generally, they're all posted up there. And I go through most of it in class. If you just did what we did in class, you get like a 70% of every single homework and then post the ones that, anyway. I don't think I'm assigning a ton of homework. I don't think I'm assigning difficult homework. I think I'm giving you options to get good grades on the homework. The second thing is the tests. We had some tests where you guys were free to go home and do them, and that was empowering and lovely and wonderful. And then we ratcheted it down and had to be in class. And I did see some people with like 85% on homework, strong scores on the tests until we came into class, and then they dropped lower. And then like 40% on the final exam. And there's two ways I can interpret that. One is they've got real test anxiety. And when they're faced with being in the classroom with me, it's really overwhelming. And if that's the case, talk to me, because I want to figure out a different way to do that. I also think there's a different class going on. I think there are people who are not really doing the homework to learn. I think you're trying to get the points for homework by looking at the answer key and copying it in some cases. I've had some frank conversations with students who did that. And they didn't learn the material, even when they had a chance to retest and do them again and again and again. So it's not surprising that they got an F on the final exam, because that was a true assessment of what they knew and they didn't know it. I hope not. It's exactly the discussion I'm trying to have right this moment. I want you to think of homework as a formative assessment. I want you to think of it as your opportunity to see if you understand the material. And you get rewarded for doing that work by getting the points. If you're just going for the points value, you're going to lose out on test points, on final exam points. You're only getting part of what you should get. Most importantly, you're not getting the knowledge. I really want you to walk out of this class smarter than when you walked in. And if you just go for the points in homework by copying down, you're not getting much. No, but I think that's a valid point, right? People do the homework for the points.
I was saying, like, you learn the material so you don't, like, I don't know, I'm just saying, like, oh, maybe a bunch of people take this class, don't like math at all. They take it, they use the grade.
I get it. This last week, I went to Park City. I know I'm not supposed to travel and I had to be very careful, but I did. And I was skiing with my daughter. And she's only skied once before when she was 6 years old, and now she's 13. And there was a period where she panicked. We're out in the middle of the slopes and she said, I don't want to do this anymore. I want to quit. This sucks. And she was struggling because we ended up on a hill that was too steep. And I said, look, I'm sorry. We're in the middle of a mountain. There's nothing you can do now other than ski. You have to learn how to ski. She said, I'll just throw my gear down and walk. Like, you'd have to walk up over a mountain of 8 feet of snow and then back down the other side and then up over the net. You can't do that. I'll see you in 2 weeks. It's not going to work. She was very unhappy. And then we got on the lift at the bottom finally. And she said, I'm sorry, I'm ruining the day for you. And I said, no, you're not ruining the day for me. I wanted to spend the day with you. I'd rather you were happier about it. And I think we're stuck here. you're going to have to ski this part down. I'd rather that you focus on getting better. So as long as you're doing it, become a better skier. And enjoy it for whatever it is. Be strong about it. Figure out how to be good at this and grow as a person. We were quiet for the rest of the ride. It was very uncomfortable. And we get to the top, and she did it. She started pointing her skis down and doing a little more focus on it and doing the wedge and doing all the things to kind of balance and get her way down. And by the end of it, she's like, I want to ski again. It's not easy, but you got to change your attitude. And I know there are people who've hated math in the past. I get it. What I'm telling you is you're stuck on this mountain. So while you're here, you have a choice about how you act about it. You can sit back and say, I've always hated math. I'm going to hate this math class too. This is going to be another failure. And you're right. If that's your attitude, you're right. You're going to be a failure. On the other hand, you can say, you know what? I really think Mr. Erlin cares about my success. He's building in some tools for me to be successful. He's available to me if I need help. I'm seeing that students can learn this stuff. It's not impossible. If I want to do this, maybe this is the chance. This is the time to try. I would ask that of you. Right? That's what I want. I want to spend this day with you. I want to do this math with you. So that's all I'm asking is this semester, think about how you could engage differently to be more successful. And if you need help, please come to me. I will help you. Okay. Hopefully you've all got the worksheet there in front of you, either Zoomers or Roomers. Today I've set up the lesson to be mostly review. It's a Monday, it's going to go really quickly. We'll see how much we can get through. Hold on one second. Okay, so we're going to start by classifying triangles. And you may remember from before, we've talked about classifying triangles by the biggest angle. So here I'm telling you that there's 3 acute angles. That means even the biggest angle would also be acute. So this would be called an acute triangle. In this case, if this angle is obtuse, somebody give me a measure that might be an obtuse angle. 160. 100 would have worked as well, right? Anything above 90, but less than 180. And of course, if this is 160, and the whole of a triangle adds up to how much? 180. There's not much left. I've only got 20 left. So maybe I'm going to have like 19 here and 1 here. Those are going to be acute, aren't they? And if I'm going to classify this triangle intuitively, you might say, well, there's 2 acute angles and only 1 obtuse. But all we care about is the biggest angle. If the biggest angle is obtuse, this becomes an obtuse triangle. And if there's 1 right angle, is there possible to have a second right angle? Or an obtuse angle in there also? No, because if we take out 90 from 180, there's only 90 left. So there isn't enough room for 90 or more for one of those angles. So this is a right triangle because that's the biggest angle. And lastly, if all 3 angles are the same, and I know that 180 is the total, then I know that any one of them must be 60 degrees. We could call it acute, but since they're all the same, there's an even better name, which is equiangular. And you're right, it's also acute. But this conveys more information. Please take a moment to do 1 through 5 yourselves. Classify these triangles by angles. Equiangular, no L. Yep. Those of you on Zoom, would you please just give me a direct message hi to let me know you're still there? 6. Excellent. All there. Great. Thank you, guys. How's the audio? You guys able to hear me okay? Okay. Right here?
Yeah.
It's exactly what we're doing.
I mean, if we go down to like the next part.
No, we'll do that in just a second. Take a look at 1 through 4, see if you got the same answers. Any challenges? Okay. What'd you get for number 5? Obtuse? Acute? Do we know?
Oh, it's the triangle.
That's number 1, right? But when we say CFE, do we know that angle E is acute? Do we know that angle C is acute? We do, because it was part of a right triangle in the number 1, right? And not a right angle. But do we know that angle F is acute? This point F is floating along this side. We don't know exactly where it's marked. There's a place here where it's acute. There's a lot of places where it's acute. If I slid it over a little bit, isn't there a place where it's right? And if I slid it over a little bit more, isn't there a place where it's obtuse? So I don't think we have the information to be able to answer number 5. I think that's a bad question, because you'd have to make assumptions. The second way we can classify triangles is by side length. If all 3 sides are congruent, remember what that's called? Good. Equilateral. Lateral means sides. What about if 2 are congruent? Isosceles. And I'll tell you, there's always a debate in the world of geometry about whether isosceles is defined as exactly 2 sides congruent, or whether it's defined as at least 2 sides are congruent, which means equilateral is also a specialty type of isosceles. I do prefer that definition, because everything that's true about isosceles triangles is also true in equilateral triangles. And then when I look at all 3 sides being different, what do we call that? Good. Scalene. Say again? Yes. What's true about all isosceles is that 2 sides are congruent. Okay, let's do 6, 7, and 8 now, please. Go. Bless you. Okay, JKM is scalene. KLN is isosceles. And and JKN is equilateral. Any questions on those? So we're now putting those two together to name triangles with both angles and sides. So let's do the angles first. What do we classify this one as by angles? Right. So this is a right. And then what do we do when we classify it by sides? Yep, right isosceles triangle. What about number 10? How about the angle first? It's an obtuse. That part's easy. How do we do the sides? There's no sides given. We call it scaling. What do you know about the three angles in a triangle? Yeah, they add up to 180. So if this is 144 so far, then this angle here must be 36 degrees. What does that tell you? Very good. Because we know that opposite an angle, relatively the size. Remember the dinosaur when it opens its mouth and you put a stick in it and So if one angle is 30 degrees and one angle is 36, then the sides opposite, those are different sizes. All three angles are different, so all three sides are different. This is an obtuse scalene triangle. And of course, this last one has all three angles and all three sides, so it's equiangular or acute equilateral. That is a lot of EQs, isn't it? Okay, page 2. Now in concept, these are the same questions. So if I look at number 14, how would you classify that? Good. We see that it's obtuse. Good. We see that it's got at least two sides congruent, so we can say obtuse isosceles. Do we know that it's not equilateral? Pretty quickly, right? Because if it were equilateral, what would be true about all the interior angles? They'd all be the same, or 60 degrees. This is not 60 degrees, therefore it's not equilateral. Okay, what about number 13? Right. You said that with a little bit of guess in your voice. You are right, but how do we know it's scalene and not isosceles? Right? But couldn't this one be 3 or 5? Why not? Well, it can be isosceles and right. We did that for number 9 here, right? We had a right isosceles. But you're exactly right that if you know the legs are different, the hypotenuse, because of the dinosaur thing, has to be the biggest side. It's got to be bigger than 5 and bigger than 3, so it can't be the same as them. So this would be right scaling. Your gut is right. But of course, this is a course on. Yeah, exactly. So in this case, we had to find the third side to talk about the sides. We were given the angle that mattered. But now in number 12, we're given the 3 sides. So is this isosceles, scalene, or equilateral? Scalene, no doubt. But how can we know if it's acute, obtuse, or right? Okay, yes and no. The one concern in geometry, you can never rely upon a figure being drawn to scale. So this is not 20 compared to this 18. It's not exactly 1/9 longer. And because of that, you can't really look at the angle and say that's a right or an acute or obtuse. The only thing we're allowed to do is expect that if something appears to be a straight line, it is a straight line. But instead, what we have to say is, I do have a trick for figuring out if this is a right triangle. The Pythagorean theorem works that way. If this is a right triangle, then I could say that a squared plus b squared equals c squared. Do we know which side would have to be a, b, and c? Or at least which one has to be c? 20. The biggest one would have to be c, wouldn't it? So let's see if it's a right triangle. A squared plus b squared equals c squared. So 15 squared plus 18 squared would equal 20 squared. 225 plus 324 would equal 400. I get 549, which is actually bigger than 400. It's not the same as 400. So is it right? It's definitely not right. Now, I'll give you the rules here so you can just plug them in and know what to do, but I'm going to ask you to think about it. I want you to pretend that you don't know the hypotenuse. You know that these two sides, when squared and then added up, make 549. So does there exist a right triangle where this side is the square root of 549? And thus, it makes a right triangle, 15, 18, and 549, square root of 549. Can you agree that that would make a right triangle? In this case, the hypotenuse is the square root of 400, not the square root of 549. So is the hypotenuse too small or too big for what's supposed to work? Too small. It's only coming out to here as a square root of 400. So that right angle has been pinched down a little bit, hasn't it? Instead of this being a right triangle, it's what kind of triangle? Exactly, it's an acute triangle. In other words, if we look at just the hypotenuse and say the hypotenuse is too small for these sides, then it's acute. If the hypotenuse is too big for these sides, then it's obtuse. And if the hypotenuse is just right for the Pythagorean theorem to work, then it's a right triangle. Now, I'm going to leave this page for you guys to work on. And I want to get you started with number 21, because this is the big problem of the day. I'm going to give you 3 coordinates like this, and I'm going to ask you to classify it by sides and angles. Step 1 is find the side lengths. How might we do that? Very good, distance formula. And I'll give it to you again here in case you don't have it at the ready. x2 minus x1 squared plus y2 minus y1 squared. So to find JK, I'd take the difference between the x's, so 1 minus 6 squared, and the difference between the y's, 4 minus 2 squared. One minus 6 is -5 squared. 4 minus 2 is 2 squared. I kept those parentheses on there because when I square a -5, I should get a positive 25 and a positive 4. Those are both under the square root sign, so I can add them and get the square root of 29. And that's okay. We can leave it like that. Don't bother turning it into a decimal approximation. It's actually helpful to leave it like this. And then we do the same thing for KL and JL to find those lengths. And if this one is a square root of 29, and this one's a square root of 37, and this one's a square root of 86, are they all the same? No. So we'd say scalene. If this is root 29, and this is root 29, and this is root 57, are 2 of them the same? Yeah, so we'd say isosceles. And then to determine whether it's acute, obtuse, or right, we do what we just did up here. We'd try the Pythagorean theorem. The square of the 2 smaller ones should equal the square of the biggest one. If it doesn't, see whether that hypotenuse is too big or too small, and use that to classify. Again, this video is being recorded, so if you want to come back and watch that again, you can. Last two pieces for today. Triangle angle sum is something we've worked on before. It says that if you've got three angles in a triangle, that they always add up to how much? 180. Easy peasy. Now, I'm going to introduce an extension to that. Sometimes it's called the remote interior angle theorem or the remote exterior angle theorem. I'm going to add that word here. And what it says is if I have a little triangle and I take one of the sides and extend it straight out, I produce something out here called an exterior angle. And let's say that this is X and Y and Z. What do we know about X, Y, and Z? They add to 180. And now let's say that I make this exterior angle W. What do you know about Z and W? They're a linear pair, therefore they're supplementary, so they're also equal to 180. And if these things are both 180, I can set them equal to each other. So X plus Y plus Z equals Z plus W. There's a Z on both sides, so I can subtract. And I get X plus Y is equal to W every single time. In other words, if I take an exterior angle, its measure is equal to the sum of the two remote, far away interior angles, not the adjacent one, but the remote ones. So in this case, the measure of angle 1 is equal to what? Like, let's say these two added up to be 100. What would, this would be 80, but then this has to be supplementary as well. So what would one become? 100 again. So this one will end up being the same as those two.
Wait, what?
I know, it's kind of cool, isn't it? Okay, left side of the class. I want you to do this the long way. Add these two up and find this. And then do the subtraction to find this one. Right side of the class, I want you to use our new rule. Find the measure of angle 1. We all get 128. Right side did extra work though. Left side had a much easier job. Okay, yeah, plenty of time, 1 minute left. Any questions? All right, your homework is to complete this 3 pages, submit it in Canvas. Excellent to see you again. I'll see you tomorrow.